Section 9.5 is the dot product. I would pause the video and write down these notes. So the dot product is a type of vector multiplication where you multiply the x components together and add multiplying the y components together, and you end up with just a number instead of a vector. The dot product is sometimes called the scalar product because you end up with the number. So if we have v and w given here and we want to find v dot w, then we're going to multiply the x components together and add multiplying the y components together. So we have 8 minus 3, which is a positive 5. And again, you end up with a number for a dot product, not a vector. So go ahead and pause the video and find w dot v and v dot v. So if you do w dot v, you end up with 8 minus 3, which also equals 5. So what we find is that it's commutative. V dot w is the same thing as w dot v. And then if you end up with, or if you do v dot v, you end up with 16 plus 9, which is 25, which would be the magnitude of v squared. So when you dot a vector with itself, you end up with just the square of the magnitude. Here are some properties of dot products. Go ahead and pause the video and write these down. So we just proved this one. Dot products are commutative. It's also distributive, so u dot v plus w is the same thing as u dot v plus u dot w. We just showed this one. V dot v is just the magnitude squared. If you dot a vector with the 0 vector, you just end up with 0. And then also, if you get a dot product equal to 0 and one of them was not the 0 vector, then that means that the two vectors are perpendicular, or we also call that orthogonal. One way we use the dot product is to help us find the angle between two vectors. So if you have a vector u and a vector v, then the cosine of the angle in between those two vectors is equal to u dot v divided by the magnitude of u times the magnitude of v. So let's try one. We're given vector u and vector v, and we want to find the angle between those two vectors. So first we need to find these three things. So go ahead and pause the video and find the dot product and then the magnitude of each of the two vectors. So if you find the dot product between the two, you end up with a negative 10. The magnitude of u is the square root of 29, and the magnitude of v is the square root of 41. So if we set this up, we get the cosine of theta is equal to negative 10 over the square root of 29 times the square root of 41. So then if we cosine inverse both sides, we get theta is equal to the cosine inverse of negative 10 over the square root of 29 times 41. You can put this under 1 square root. So then we can use our calculator to calculate this. Make sure you're in degree mode and then plug this in your calculator. So if you calculate this, you end up with theta is equal to 106.858 degrees. So this is the angle. If you were to graph vector u and vector v, this would be the angle between those two vectors. So here's another vector v and a vector w. Go ahead and pause the video and find the angle between these two vectors. So I started with finding the different pieces. V dot w is equal to negative 13. The magnitude of v is equal to the square root of 29. The magnitude of w is equal to the square root of 10. So then I set up my cosine equation. So cosine of theta is equal to v dot w divided by the magnitude of v times the magnitude of w. So then I cosine inverse both sides and end up with theta to be 139.763 degrees. So now we're going to talk about orthogonal or perpendicular and parallel vectors. So sometimes we want to decompose a vector into two different vectors. One that's parallel to a given vector and one that's perpendicular to that given vector. So for instance, if we have vectors v and w, and we want to split vector v up so that part of it's parallel to w and part of it's perpendicular to w, this down here is how we would do it. So v sub 1 would be the part of v that's perpendicular to w. So you take the dot product v dot w and divide that by the magnitude of w squared. That's a number. And then you would multiply that number by vector w. So we would end up with another vector. And then that's part of vector v. So if you take that part out of vector v, so you subtract it from vector v, that leftover part is going to be perpendicular to vector w. So we're given vector v, which is I hat minus j hat, so this vector here, and vector w, which is I hat plus 2j hat, which is this vector here. And we want to split vector v up into two vectors, v sub 1 and v sub 2, where v sub 1 is going to be parallel to vector w, and v sub 2 is going to be orthogonal or perpendicular to vector w. So first we need to find v dot w and the magnitude of w squared. So go ahead and pause the video and try that. So v dot w ends up being -1, and the magnitude of w squared ends up being 5. So v sub 1 is parallel to vector w. So we have v dot w divided by the magnitude of w squared times vector w. So v dot w is -1, the magnitude of w squared is 5, so you end up with -1/5, and you want to multiply that number by vector w. So go ahead and pause the video and find vector v sub 1. So you end up with -1/5 I hat minus 2/5 j hat. So if you graph that, you're going to go to the left -1/5 and down 2/5. So it's on that same line as w, but it's going the opposite direction. That's still considered parallel. So we took part of vector v to create vector v sub 1, and we want whatever's left over, so v sub 2, is going to be our perpendicular or orthogonal piece. So we just do vector v, our original vector v, minus the vector that we just found. So go ahead and pause the video and do vector v minus vector v sub 1. So you end up with 1 -1 minus -1/5 -2/5. So v sub 2 is 6/5 I hat minus 3/5 j hat. So when you graph that, you're going to the right 6/5 and down 3/5. So you end up with this yellow vector here. So what we did is we split vector v into two different vectors. One that's in the same line as vector w, v sub 1, and one that is actually perpendicular to vector w, which is v sub 2. So the last thing we're going to talk about is work. Work is force dot distance traveled. So whatever force you're exerting over how long you're exerting that force for, or how far you're exerting that force for. So we have a child pulling a wagon with a force of 20 pounds. When you pull on the wagon, you're not necessarily pulling perfectly horizontal. In fact, this one is pulling at an angle of 30 degrees. So we have this kid pulling at an angle of 30 degrees. The force they're exerting, or the magnitude, is 20 pounds. So what we want to do is we want to find the work done by moving the wagon 100 feet. So first thing we have to do is we have to find our force vector, which means we have to find our x and y components. You know the hypotenuse and you know the angle, so you can use SOHCAHTOA to find x and y. So go ahead and pause the video and find your x and y components of this force vector. So if you use SOHCAHTOA, you end up with the x component to be 20 cosine 30 degrees, or 10 root 3, and you end up with the y component to be 20 sine 30 degrees, or 10. So your force vector, the force that this kid is applying on this wagon, is 10 root 3 I hat plus 10 j hat. So now we want to find the distance traveled vector. So distance traveled, this wagon's only traveling in the horizontal direction, and this kid's like magically pulling it up in the air. So it's going 100 feet in the x direction, so your distance vector would just be 100 I hat. If it helps you, you can say they're not going at all in the y direction, so plus 0 j hat. So now you have your force vector, and you have your distance traveled vector. Now you can calculate work. Work is force dot distance. So go ahead and pause the video and calculate the work done on this wagon. So dot product 10 root 3 times 100 plus 10 times 0, you end up with 1,000 root 3. You multiplied feet by pounds, so the unit on work is foot-pounds. So the work done on this wagon to make it travel 100 feet is 1,000 root 3 foot-pounds. So remember, whenever you're doing a dot product, you're going to end up with just a number, not a vector, and it's always multiply the x components together plus multiply the y components together.